Welcome back to this question. As we said before, we need to find the approximation for this series. The first part of the question is asking us to show that this series is convergent. So here you go ahead and apply the alternating series test, which means you have to check Pn, is it decreasing, and the limit goes to 0. I will leave this part for you. I'm sure you can handle it easily. It's good practice to do it. So let me just go to the second part, and he's asking me of the following. He's asking me how many terms. How many terms? It means he wants me to find n. Now, how do we find n? We go back to our formula, as I said it before, that I write Pn plus 1 less than the error he's giving to me. It will be an inequality, and I find n. Of course, if he said approximate using this n, then I need to just add them up to n. But now he's just asking me to find how many n. So the first step, we need to find what is Bn. So my series looks a little bit strange, so I just need to fix it up. Because usually alternating series, I should see -1 to the n. So let me just break it down. It would be -1 to the n, and 3 to the n. Just take n to the -1 and take the n to the 3. And from here, I think my Bn is clear as the positive part, which is this one. Next step, I need to write Pn plus 1 less than the error that I have. And I just write it down here. Oh, sorry, here we write the number of the error, which is 0.005. Now, this is an inequality. You need to move things around. So let me take everything here. I will just do cross product. So this is 1. I'll just do a cross product. This will be 0.005 less than n plus 1, 3n plus 1. Now 1 over 0.30, sorry, is it 3 zeros here? Yeah, 3 zeros. That is about 10,000. So this will be, I think, 5,000. 2,000. And here n plus 1, 3n plus 1. And now all what you need is take your calculator and try, because there is no way we can find an exact answer. So here we just need to use your calculator to try to find n. Substitute n equal 5 and check. Do we get more than this? Just to be exact, I will return it back to its origin. Now just take your calculator, plug in n here, and check, do we get this or not? That's all what we need to do. Is that clear? So just try 5, try 10, try 7, and then whenever you get something greater than this one, that's your n. Maybe this is not the perfect n, maybe there is a smaller n that will work, but it doesn't matter. He didn't say find the minimum n. If he said find the minimum n, you can just take your number down and down and down and take the minimum one, and through this you will find 1n. And that's exactly how we solve this question. It's kind of here trial and error because sometimes those are a little bit difficult to deal with. Now let me go to the question number 7. and said approximate the sum of the series correctly up to 4 decimal places. So we have 4 decimal places, and we need to do them in that way. Okay. Now 4 decimal places, it means, if you remember, we said what will be the error? The error will be 0.0000. Those are correct, and then the next one could be any number. It doesn't matter. We just write it 1. So we have to do the same exactly what we just did before here. So we have here Bn plus 1 should be less than the error, and Bn is 1 over 3n plus 1 n plus 1 factorial less than 0.00001. Do the cross product, it will be 1 over 0.0001 less than 3n plus 1 n plus 1 factorial. I think now you can just plug in numbers. If you plug in maybe I think if you plug in maybe 7 could work. Maybe 7. Try it 7 should be fine. And let's say the answer is 7. I'm most probably yes, 7 could work fine. Yeah. So I'll just go ahead and say it's 7. Maybe less, but 7 I think it will work. Now, if n is 7, all what you need to do is you just say that your series -1 to the n, your series is approximately, and then you start adding from 1 to 7, which is plug in 1, it will be -1 over 3 plus plug in 2 will be 1 over 9 times 2, 18, minus plug in 3, 27 times 6, and then plus until you plug in 7. So 3 power 7, it would be a minus, by the way, and then 7 factorial. Okay, this is how we approximate the series. Of course, the answer will be correct into 4 decimal places. All of you will get the same answer, whether you use 7 or you use 8 or you use 9, 10, 11, doesn't matter. All of them, they will give you the same 4 numbers at the beginning after the dot. So there is a dot here, and then the first 4 will be the same, and then here everyone will have something else. But we said it doesn't matter because in the question we ask you to find only the 4 places. So if it is multiple choice question in the exam, we will only give you those 4 correct ones. So it doesn't matter the answer you use 7, 8, 9, you must get those 4 numbers in all cases. So by this we finished the topic, the subtopic of finding the error in the alternating series.